You are standing in your backyard, but you are actually standing in a laboratory. The air above your pavement is 10 degrees hotter than the air above your lawn. The humidity near your tomato plant is dropping faster than the air inside your house. You do not need a degree in meteorology to see it. You just need to understand that your garden is not a static picture. It is a dynamic fluid system. If you can learn to read the numbers, you can stop fighting nature and start engineering it. Most gardening advice is anecdotal. Water in the morning. Add coffee grounds. Compost is good. These are rules of thumb, not laws of physics. To truly make your garden a force for good, conserving water, sequestering carbon, and cooling your neighborhood, you need to shift from intuition to measurement. This is where science and math intersect with dirt. The most critical, yet overlooked, metric in sustainable gardening is evapotranspiration. ET is the sum of water evaporating from the soil and transpiring from the plants. It is the engine of your garden water cycle. If you water based on a calendar, you are guessing. If you water based on ET, you are managing a resource. Water does not just disappear, it moves. It moves from areas of high vapor pressure to low vapor pressure. Wind speed, solar radiation, temperature, and humidity all dictate this movement. By understanding these variables, you can create microclimates. For example, a dense row of native shrubs can reduce wind speed by 50% in the space behind it, drastically lowering ET for the delicate herbs planted there. This is not just about saving water. It is about creating resilience against drought and heat waves, which are becoming more frequent and severe. You do not need a weather station to start. You need a rain gauge and a thermometer. Track your rainfall. Track the temperature. The rule of thumb in horticulture is that plants need about 1 inch of water per week. But this is an average. In a heat wave, ET can double. In a cool, humid week, it can halve. Here is the niche skill: calculate your deficit. Deficit equals ET minus rainfall. If the deficit is positive, you irrigate. If it is negative, you do not. This simple equation prevents overwatering, which causes root rot and leaches nutrients into groundwater, and underwatering, which stresses plants and reduces their carbon sequestering ability. If your garden is a heat engine, what is its fuel? Consider this. A single mature tree can absorb the equivalent of 2.5 tons of carbon dioxide over its lifetime. But it does not do this alone. The soil beneath it, rich in mycorrhizal fungi, stores 3 times more carbon than the plants above ground. Now, here is the twist. Does tilling your soil help or hurt this process? Most people think tilling aerates the soil, helping roots grow. But from a physics and chemistry standpoint, tilling is like opening the lid of a soda bottle. It exposes ancient, stable carbon to oxygen, causing microbes to break it down and release it back into the atmosphere as CO2. So, the science question for the modern gardener is, how can we farm and garden without turning our soil into a carbon emitter? The answer is regenerative agriculture, no-till, cover crops, and mulch. It is a shift from growing plants to growing soil. When you apply these principles, you are doing more than growing food. You are conserving water by watering only when the deficit is positive, reducing strain on municipal supplies. You are sequestering carbon by avoiding tilling and using cover crops, turning your yard into a carbon sink. You are cooling your city by understanding microclimates, planting strategically to reduce the urban heat island effect, lowering energy consumption for air conditioning. This is not just gardening. It is applied environmental engineering. And it starts with a thermometer, a rain gauge, and a willingness to let the data guide your hands. Asterisk.